decrease, it can go down, things can change quite a lot. So that's a problem for you that you will have to address, because it's not okay to have a model losing performance over time in production. So why does this happen? Well, we actually got quite a pretty obvious example going on right now. COVID changed buy patterns, changed usage patterns, changed supply chain throughputs. It changed everything basically. And models that are running right now weren't designed for these scenarios. So they simply didn't have any data to train them on. And we actually moved to data that was never seen before. So the distribution changed, the models need to change, things need to be adjusted correctly. So this is actually quite a big motivation for model monitoring. Some of the challenges that model monitoring cover are listed here. If you have any questions about any of the concepts that we talk about here today, feel free to ask in chat. Someone from the team can give you a definition or help you out understand it better. But just in general, you can have data distribution changes, you can have concept drift, you can have concerted adversaries. This one typically raises a few questions. It's basically when you're dealing with an adversarial use case, or when somebody's trying to exploit your model. It can also deal with outliers, data quality issues, pipeline health issues, all these problems. So just keeping it to one sentence, what is model monitoring? Model monitoring is the process of closely tracking the performance of machine learning systems in production. And it is typically divided into two levels. You have the operational level and the functional level. Operational typically is ensuring that your infrastructure, your infrastructure is up, that your uptime, that your latency is within the acceptable parameters, that everything is working fine. And then you have the functional level, which is more regarding the performance of your model, the data that you have. It's more a data scientist job. So it's something like ensuring that the data quality is up to standard, ensuring that the data isn't drifting, ensuring that the model performance is as you intend it to be, all this. So where does model monitoring fit? Model monitoring kind of fits on this space. So you basically take the serving logs, you have the data set and feature repository, you access your artifacts and your metadata, and then you detect drift, you detect concept drift, you continuously evaluate your model, you design your dashboard so you can see the progression of your model and all the important KPIs that you want to keep track of, and you set up alerts to make sure that if anything goes wrong, you get alerted as soon as possible. So on functional monitoring, this can be typically divided into three parts. Data, where you look at inputs like data quality issues, feature drift, outliers. Model, where you actually look at your model, look for model drift, model configuration, versioning, and concerted adversaries. And then you have the predictions, so where you actually evaluate the performance of your model, if you have prediction drift, if you have biases, if you have bias drift, sorry. So this is where you basically look at all that. So this is functional monitoring, and it will be on this part that we'll be focusing during our talk today. So what are the typical steps for actually a monitoring system? Normally you have to deploy your model, obviously, and capture both the inputs and outputs of that model. This can be a problem if you have PII or something similar, and you need to be careful. But in general, these are the type of things that you need to enable. Then you need to define and store your baselines. So defining what is your baseline statistical distribution of data, define what are the thresholds for missing data that you're willing to accept, define what is your baseline model to which you want to compare, all these things. And then you actually go into the monitoring both for data and for the model. You can do one or both. You can just go to wherever. Normally you go for both, but there might be some case where you just need one. And finally, you actually go into the dashboarding and the alerts. So for today, we'll be demoing 3 tools. We'll do some quick intro to each of those tools. And we'll be using churn, which I believe is an example that every data scientist is familiar with. It's basically making sure that is basically predicting that a client is going to stop using your service or not. So in this case, we're using data from a US mobile provider. We have a very small data set, this is just as an example. So we have 5,000 records with 20 customer attributes. So something really simple just to help you go along with it. And now Boyan will be talking to you about model monitoring with SageMaker. So if you want to take it over.
Yeah, thanks, Theo. Let me just show the screen. Hi all, I'm Boyan and I will give a quick intro into monitoring with SageMaker Model Monitor. First, what is SageMaker Model Monitor? It's a very powerful tool that allows continuous monitoring of ML models in production and in real time. You can configure alerts that notify you when there are deviations in the model, quality, and trigger actions if any drift in the model performance is observed. You can also visualize the result of the monitoring in Amazon SageMaker Studio, view the details of any monitoring job run, create charts that show you the baseline captured values for any metric that the monitor job calculates. About model monitor features, we have four different. We have data quality, which helps detect change in data schemas and statistical properties of the independent variables, and alerts when drift is detected. Then model quality, it's for monitoring model performance characteristics, such as accuracy or precision or F1 score in real time, and also allows you to ingest the Groundthrough labels collected from your app. The next one, model bias, it's actually the model monitor is integrated with Amazon SageMaker Clarify to improve visibility into potential bias. Although your internal data model may not be biased, change in the world may, as the other said, may cause bias to develop over the time in the model that has already been trained. And the last one, model explainability. When a change occurs in the relative importance of future attributions drift or detection alerts. How does it work? So the following diagram illustrates the high-level workflow of the monitor. At the first row here, we have, let's say, the standard pipeline for ML, and the rest is actually the part how Amazon SageMaker Model Monitor works. And the process looks like this. You start with an endpoint to monitor and configure a fraction of inference data to be captured in the real time, and it's stored in the S3 bucket. Then Model Monitor allows you to capture both input data sent as at endpoint and predictions made by the model. Also, you can create a baseline job to generate statistical monitoring and attach it to an endpoint through a schedule. And for model monitor performance characteristics such as accuracy and precision, it allows you, as I said, to ingest inference Groundthrough from your app and to compute the model performance metrics. As pros and cons from SageMaker model monitoring, I can say that from pro side, we have scheduling the monitor runs. So you can specify how often do you want to get reports. Then visualization of the data drift. SageMaker has like in-house visualization, easy creation of new charts, and it also has like real-time monitor model and data quality. On the cons side, it only works with tabular data. Then supports only endpoints that host a single machine and does not support like monitoring multi-model endpoints. Also, if you have like a pipeline, it supports monitoring inference pipeline, but capturing and analyzing data is done for the entire pipeline, not for individual containers. If you have more than one, and there are like a bunch of setup that you should do in order to make this thing work. Now I will go to my demo. Okay. So in this demo, at there's a very simple example. I will show how to
just a heads up.
Start
Could you make it a little bit bigger?
Mm-hmm.
Is that possible?
Yeah.
All right. Thank you. There we go. Perfect.
Is it okay now?
It's great.
Okay. Thanks. So it's a very, as I said, very simple example how to start model monitoring process, and there are like two high-level steps. The first one is to deploy a model, and then just configure the model monitor and see the results that you will get. So the first one can be done in various ways. For example, you can deploy your own container with a model and endpoint configuration, or maybe you can use some pre-built image from Amazon, as I will do in this example. Also, you can choose like between train your model in SageMaker, or maybe just pass pre-trained model, and so on. At the beginning, I should mention just that you will need an AWS account with certain privileges, like accessing S3 bucket, for example. At the start, we just import all the libraries that we need, and then we continue with a lot of setup, like we get the session, the role, region, and then specify all of the prefix and path to the S3 bucket that we will use. Some short tests about S3 bucket in order to check if we have access or not. And then the next step is to upload the model. Then we should create a SageMaker model entity. As you can see, we're using already prepared image from Amazon, and where we will deploy our model, and then this is how the model actually is deployed. I already executed this notebook because for some of the steps like endpoint creation and model deployment, it takes some time. For, I don't know, maybe 10 minutes in order to deploy your model or create an endpoint. And then we when we have this model deployed, we will attach predictor to the model, which we will use in order to get predictions from our model. And when we are finished with that, the next step is to create a baseline. So we are generating the this baseline, like executing some predictions using the validation set. And when we finish with this thing, we can check our validation with predictions look like. This is the result that we are getting. And after that, the next step is to upload our predictions to our S3 bucket, so we can later use this baseline. Now, when we have our baseline, we can explore the results from the baseline, and but before that, we should create our first baselining job with, as I said, validation and dataset prediction. Again, a bunch of setuping. We are choosing. We are setting our model quality monitor. How many instances we will use, what type of instance, and so on and so on. Put some name on it, and then execute the baseline suggestion job. Again, some settings about the problem type, inference attribute, probability attribute, and so on. When this thing finished, you can see your results and just describe them. It's provide like baseline statistics for all of your attributes and some other measurements. So right now, our baseline is set up, and we can start our model monitoring. So the next step should be like set up continuous model monitoring. But before we start with actual listening and see how our model is working, we should also provide some ground truth. So first, we are sending some traffic to our endpoint in order to generate some data. So like to get some predictions. And here you can view how the captured data looks like. You can structure it just to see what you are getting as a result of this monitor process. And as I said, the thing that we should do is start with before we are creating a monitor schedule is generate ground truth. In this case, we are generating some synthetic ground truth. Again, a lot of things that you should set up, a lot of paths, upload records from our data, and when we are finished with generating fake ground truth, we can start that thread and create a monitor schedule where we specify the name, endpoint input, and create the actual monitor schedule. Again, you should put some to set up some attributes here, like threshold, destination for the output data, input data, and so on. And after some time of working of your monitor, also you can specify how often you want to be run. You can see the data that actually the data generated from model quality monitor. This describe it, see how many executions do you have, and so on and so on. One interesting thing that you have when using SageMaker model monitoring is actually that, as I said, you have in-house visualization And also it provides like test interface where you can just send some data to your endpoint and see how what kind of results you will get. And also you can observe your data quality and model quality. You can see all your executions. As I said, you can select different metrics in order to get some fancy or not that fancy charts, and so on. What is interesting here, if you see the code, actually we will just create model quality, but we also have here the data quality schedule. And if you want, I don't know, model explainability or model bias, the studio itself allows you to create a model monitoring schedule from here. So if you don't want to create by writing Python code, you can do with this wizard. Just follow the steps, and you will get appropriate model monitor for that kind of data or feature. That's it on my side. I guess Nicholas is next.
Yeah, thank you, Bojan. Let me share my screen. And please let me know if you can see it. So I'm going to talk about Wallace. Well, when you use a reveal tool, just as Bojan explained, SageMaker in the case of AWS for monitoring, SageMaker Model Monitor, or SageMaker Clarify, this is so specific and only works within the cloud vendor environment in most of the cases. But what happens if you want to have an agnostic solution that works everywhere, or maybe you want to migrate your models, or you already have some models to another cloud, like say GCP or Azure, or you want to have a standard solution for monitoring all your models regardless of the cloud or your your vendor. If that's the case, maybe you want to consider something like Wallace. Wallace is an open source logging agent that monitors your machine learning models. So it's logging input. Well, it uses Python for that. It's logging your inputs, outputs of your model, of your actual predictions. And how is doing this? It's not actually logging your raw data, but instead logging what is called that data profile. And well, how this works, how this actually works. So data profile is just well, some descriptive statistics and some, well, yeah, descriptive statistics around your data. For example, mean, median, well, your and another, for example, for categorical variables, the frequencies, and so on. And you can install Wallace. Wallace is open source, the package, you can find it on PyP repository. You can install it and use it in containerized environments, just doing a pip install, or well, using the package manager of your preference. And that's it. It's really easy to integrate. It's really easy to integrate with any model that you have. For example, if you are deploying your model with Flask or some other framework, for serving your model, you can do it. Wallace will start sending data profiles to a destination of your preference. It has the possibility of sending your data to their own platform, their software as a service platform called YLabs, or you have the possibility to send your data to AWS S3 or another blob storage services that you can find out there, like, for example, AWS blob storage, Azure blob storage, sorry. And you can configure all of this just using some configuration file and YAML file. I will show you more of this later in the example. Also, if you want to start monitoring your data from a centralized platform, as I said, they have YLabs. YLabs allows you to monitor your models, and well, I will show you more on that later. For example, if your model data start different for your training data. Well, the data that is coming to your endpoints start different if you have some data drifting problem, or some, I don't know, if you're sending null values for whatever reason, you don't have a schema validation or something like that, you can monitor your models from the Wallace platform. So I want to show you a little demo on how Wallace and Wallace work together. So basically, here I'm training a model. I'm using the same data that Boyan used. The shorn data is also that data set that you can find out there pretty easy. You can see it's a really straightforward training. I'm not doing anything fancy here. So once I have I'm training a random forest classifier from an ensemble model from a scale and serializing that artifact into with job tip. Yeah, that's what you generally do. And well, saving the test data to first sending requests later. So well, I'm creating an application here and serving it with Flask. You can see here. And I'm using Flask for saving the application. It has two routes, one for checking just the health, if it's healthy, and the other one was for getting our predictions. And how I'm packaging Wallace here is basically packaging two things that are important. One is the Wallace YAML file with all your configuration. For example, here you're seeing that this one here, you're seeing that I'm specifying a type of writer. They call it writer, the way of setting up your destinations. In this case, we're setting up Wallace platform, but you can also told you can set up S3 or others and setting the data format that we want. And in the other hand, we have the environment file. You can't see in here because you can see hidden files in Jupyter, but I have it here in the same folder that where app.py is. So basically what I'm doing is just setting up, well, this is my Wallace YAML, the API key for Wallace platform. I forgot to say Wallace is paid. It's a paid service, just a SageMaker, but it has the advantage that you can use it no matter the cloud vendor that you have, or no matter where your models are, because you can package it easily. And well, and I have other parameters, for example, the organization ID for the Wallace platform and the dataset ID. In this case, is model 1. And well, first, as you may see, I'm setting up the baseline. The baseline basically is my training data. So I'm setting up that one, just logging that into Wallace. So first I'm defining here a session, passing that file with my configuration, setting up this logger. So what this logger is doing is just, well, receiving a dataset name and the dataset timestamp. So I'm setting up a dataset timestamp, one in yesterday. So you can see here that I'm setting up yesterday and logging my training data basically. So remember that I'm not logging the raw data, but instead I'm logging the data profile. That's one is kind of the summarization of my data. So this comes handy when you worry about security, because you're not sending your raw data, so you have that problem, that issue with security, because you're sending some statistics and not your raw data. So basically, well, let me first start the server. I'll start a development server with Flask. You can see here that this is just a development server. This is the endpoint. So sorry, I'm start sending a request to the help endpoint and getting around 200 response. So it's okay to send data. I'll start sending data from the test dataset. And you can see here that, well, that's the data that I sent. Well, let's go to the Wallace platform so to see how this reflects there. So this basically is the Wallace platform. Here you can see that I have multiple, let's give it a moment. I have multiple models. The model that we're working with is the model one. So let's go there. So view the summary dashboard that we have. You can see here that we have I have 2 data profiles. I already test this with other data, well, we have my trained data profile and other data profile that I tested before. I have here configured some monitors, for example, for the distribution drifting, if I have any missing values or something. And you can configure here the monitor baseline profile that you want to use. I wanted to use the ones that corresponds to the training data. So you can set up here from the UI. It's really easy to do. And well, let's actually go to compare the profiles. So you can see, for example, I have here one data profile that corresponds to the data that I sent to my endpoint. And if I want to add another data profile, I mean, this is just the case if you want to compare this manually with others' data profiles, you can just put this, click on this, and you can see that we have our, sorry for this, we have our both distributions for every feature that we have. Also, we have our distribution for the class, the predicted target. And yeah, that's basically what I wanted to show you. I mean, Wallace is still a relatively new tool out in the MLOps market. So not only Wallace, but Wallace is the open source package, is relatively new. So if you want to know more about it, you can go to their Slack channel or, well, check the rep. So I will leave you with Alex and evidently I.
Okay, thank you, Nicholas. I think you're still sharing your screen.
Yeah, sorry. Pass it. There, you have it.
Okay. 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 Hello, everyone. So far we talked about SageMaker, so the solution by AWS, fully managed. Then Nicholas told you about Ylogs, which is also very complex, very rich in terms of features. But not everyone has extremely complex machine learning models. Maybe you are just starting with a new model, or you're just starting with not a lot of data. So you just want something simple that allows you to have monitoring very quickly without a lot of boilerplate. So let's say we decided to go down on complexity and also in terms of the available features. So I'm going to tell you about Evidently AI. So Evidently AI was created by a very small company that they were founded in 2020, if I'm not mistaken. And they basically came up with a Python library that allows you to evaluate and monitor the data quality, your data quality and your machine learning models. It generates interactive and static reports from your models and from your data, and you can either run it manually or integrate it in data pipelines. And then you can use those visual reports for ad hoc analysis, or you can integrate the reports in other tools. I will tell you a bit more about this in the demo. So how exactly does it work? Basically, Evidently is based on always 2 sets of data, so the reference data set and the current data. And depending on the context, reference and current can correspond, for example, to your train and test data sets, or to your development data set versus your production data set, or your development model and production model, and can also refer to your reference data, the data that you use to train your model, and the fresh data, the data that your model is receiving when it's deployed. Then Evidently allows you to choose 6 available reports. You can't configure them, so the configuration is static. They have reports for data drift. Then they have 2 reports for target drift, both for numerical and categorical targets. And then they have 3 different reports for model performance, depending on the type of model. So regression models, classification, and probabilistic classification. As I told you before, the results are available via an interactive dashboard, for example, on Jupyter Notebooks, but you can also export the reports as an HTML file or as a JSON file. So better than telling you about it, it's to show you how it works. So I prepared a very simple demo. Okay. So in case you, I think you are able to see my screen. So in case you're not seeing my screen, the Jupyter Notebook, please let me know on the chat. So I recommend that you visit their website, evidentlyai.com. The documentation is very rich. They have lots of examples. It's very easy to set up. So basically, you start by installing the package using your favorite package manager. I use Conda, but you can use pip, of course. Then in case you want to explore your reports interactively on Jupyter Notebooks, then you need to install an extension on Jupyter Notebooks, this is also very clearly documented on their website. Then I start by importing the necessary libraries just to run the model that the guys already told you about. Then regarding evidently libraries, I'm importing the dashboard module because I want to create dashboards on Jupyter Notebook, and I will be showing you 4 different reports. So I'm importing this, and then I'm also importing profile. Profile is the name evidently gives to the JSON reports. I'm only going to illustrate one of the reports, so I just import one of them. So this is where I set up the problem. I'm not going to tell you about it because you already heard about it twice. Basically, I end up with this very fancy data set. I'm only using numerical features for this example. And the first thing I do is splitting my data set into training and test. And if you remember, before I told you that evidently expects you to have a reference and the production data set. So in this case, our reference will be our training data and our production will be the test data. So this is not the best example in the world because we don't expect to see any bias or any weird behavior in the data because it comes from the exact same distribution. So, but let's do that. Then I train a simple classifier. And from now on, from the test data, using the test data and the classifier, I can predict if a customer is going to churn or not. So, but let's go to the interesting part. So as I told you before, evidently, supports 6 different types of reports. Right now, you have the data drift reports, numerical and categorical target drifts, and then model performances for regression models, classification models, both binary or multi-class classifiers, and finally, probabilistic classifiers. The first thing you need to do is to map the columns on your data set on a dictionary so that evidently knows where to look on the data set. So basically, I'm setting the target column, which is the churn column, and I'm saying that the numerical features are the feature, all the features. So they are all numerical features because I dropped all the categorical ones. Then I'm initializing a dashboard and I want to see the data drift reports. The actual calculation is done passing the column mapping and the train and test data sets, which are my reference and production data. Then I can, as I told you before, I can save the report both on HTML or take a look immediately on the Jupyter Notebook. First, I will create the HTML, which is this file. So I already created it. It's this file. So I'm going to go in detail over this report. So, but basically this is an independent file that you can upload to S3, that you can send to your stakeholders. You can do whatever you want with it. It's an interactive report that we will see. But let's look at the report generated on Jupyter Notebook. So again, it's the same report, exactly the same as we saw on the HTML. The first thing that we see is that drift was detected for 0 out of 12 features. We were expecting this because the train and test data have exactly the same statistical features. So for each feature that you use, you will get a row on the report. You will have the report allows you to immediately compare the distribution of the reference and current data. In this case, you have no data drift for any of the features. If you dig down a bit, you can visually inspect the drift on the data, and you can look at the data distribution, comparing reference and current. So you can do this to all the features for the data drift report. Next, the target drift report. Again, I initialize the dashboard and I say that I want a categorical target drift because my target is categorical. I calculate the report and I can see it immediately. Again, no drift was detected. You can compare the distribution, the frequencies of the two classes, both on the reference and on the production data. You can look check the behavior by feature. So for the two data sets, for the reference and current data sets, for both classes, 0 and 1, churn or no churn. And you can do this to all features. Just a quick reminder, it's so the information, I guess you agree with me, I believe you agree with me. So the information it gives you, it's very rich. It's not something like mind-boggling, but it's something fundamental. The information is very rich and it's extremely easy to generate these reports. So finally, the classification model performance. The procedure is basically the same. You create the mapping for the columns. Then I'm predicting the actual data, predicting the labels from both from the train and test sets. And then I create the report. So the classification performance reports always gives you these 4 metrics, so accuracy, precision, recall, and the F1 score for both the reference data set and for the current data set. Obviously, we are classifying the same data where we train the model, so obviously the metrics are very high here. On the test set, they are a bit lower. Then the report also shows the class representation for both the reference and current class. As expected, they are almost 50-50. You have the confusion matrix, again, for both the reference and the current data, and the quality metrics by class, again, for both data sets. So once again, it's a very rich report. You can't really customize it, but it's very rich. It's an excellent way to start monitoring your models, and it's extremely easy to implement and integrate even on already existing models. And finally, I forgot about this part. So the model performance report also gives you the classification quality by features. So again, for both data sets and for all the features. Finally, so when you are starting, you will probably be interested in having your reports on Jupyter Notebook or even on HTML. But then you will probably move on to having a proper data pipeline. Maybe you have, I don't know, Apache Airflow running or something managing a bunch of cron jobs. So you can simply add the creation of these reports to a cron job, and that's what I show here. So I'm creating a profile, which is basically a JSON report with one of the reports. In order to generate the report is again the same thing, and this will generate this JSON file. So this JSON file, you can upload it to S3. You can use it, for example, on a BI tool like Grafana or something like that to do further analysis. You can use it on another tool to generate alarms or something like that. And finally, I want to show you that you don't need to explicitly write Python code to generate these reports. You can also generate the reports directly from a terminal. Basically, you just need to pass. So you call Python eventually calculate dashboard. you pass a reference data set, a current data set, and you need to create a config file. So basically the config file, I have a small example here, tells you tells evidently the format of the data and what types of reports you want it to generate, and then it will generate a JSON file like this one, again, that you can incorporate in your data pipeline. And so this is what I wanted to tell you. I will pass my turn to Diogo again.
Okay, so moving on to wrapping up. Now we know a bit. We've did a few model monitoring tools. We discussed 3 of them, and so now you no longer have that excuse. So please don't be that guy. Ops already has a lot of work with infrastructure, keeping things up to speed, and it's your model. It's your responsibility. You need to basically make sure that your model is working properly, while the ops team already has to make sure that your latency and your structure is up. So here are some other competitors. Obviously, we couldn't cover them all during this talk, and these aren't even all there are. These are just some of the main players. And obviously, we haven't tried them all personally, but there are some good examples here. For example, MLRun and Aporia, in my opinion, have a similar feel to MLflow. Great Expectations is very commonly used, and there was actually a cool presentation here in the community last week. Coming up will be Amy from Fiddler, which can also be interesting. She'll be discussing concept drift, and all these tools basically all fill the same role and have similar features, but they're very specific for some use cases, and they might improve. And in the end, it basically boils down to personal preference and how well it integrates with your existing system. Yeah, go ahead, Dimitrios.
So I've got a ton of questions, but I don't want to cut you off here. So if you want to finish first, and then I'll jump in.
Yeah, okay. Yeah, so then basically what's next is, I hope this helped you basically with setting up your model monitoring if you don't have one already. And if you do have one, it will help you improve your current model monitoring just by exploring new frameworks that may be better or maybe better adjusted to your tools and your integrations. Now you know a bit more about different tools and how well they might work in your specific problems. Here are some quick take-home tips and resources. When we provide the slides, these will all be links. They are basically what we believe are good starting points for each of the tools we discussed. There's also the GitHub link for the different demos today. And yeah, feel free to reach out to any of us or to Loka in general for help, or if you just want to discuss some ML tools. And just to close up, ML is never done. This is something that all data scientists, ML engineers, whatever you do, if it's related with data science, you know that the work is never done. And here at Loka, we're always looking for some cool people to help us with this never-ending work. So if you're interested, please ping us and join us. Thanks. Yeah, Dimitrios, you can go ahead.
All right. So cool to see this, especially because we've been working on model monitoring compare page on our MLOps community website. And one thing that came to mind as I was watching all these different demos and thinking about it, you have the 2 open source tools that you showed, and then you have Amazon, and you mentioned there's others that like SageMaker, like Fiddler, and then some like Superwise are sponsors actually of the community, who are going to be on next week talking about monitoring more, and then Fiddler the week after, as you mentioned. I'm just wondering what use cases, when does Amazon feel like the best way to go, and when does something because there was the explainability within Amazon, right? And you have explainability within Fiddler, for example, or you have explainability within Arise. Have you figured out what the best use cases are or best preferences? Are there any hot tips you could tell us about for when to choose one or the other?
Yeah, we actually tried for this exact presentation to basically do like this huge table with like complexity, automation, use cases. And as we discussed, like we all went and looked at different tools, some of which we didn't know, some of which we did know. And in the end, it came a lot to, it depends on exactly what you're doing. So for example, if you're working on Amazon and you already have everything set up in AWS, yeah, maybe SageMaker is a good solution. SageMaker Model Monitor is a good solution for you, but it might not be because your use case has like this specific detail, or you simply dislike the appearance of SageMaker Model Monitor and you like Arise better or Great Expectations. So in the end, there are some differences, but the most important difference ends up being your personal preference.
Awesome. Super cool to
Well,
hear.
I mean,
all of
and
this.
I would add that if you are within the AWS ecosystem, they do a very good job, at least AWS, to keep you inside the ecosystem. And the way they do that is that at least SageMaker, they provide a bunch of extra services, like for example, the pipelines, the autopilot, the model monitor, the clarify, that they are basically free, right? But you need to be within the ecosystem. And you're not paying for these services, but you are paying for the instances. So when you're inside when you are already using their infrastructure, I think you basically need a very good excuse not to use their tools, right?
That's how they keep you hooked. They're
Yeah.
smart about
Exactly.
it. They know for sure. Sweet. Well, this has been really cool. I thank you all for joining and for your time, for giving us these deep dives. It's really like the short deep dives on these tools and how to do different things with the tools. It's something that I've been thinking about quite a bit because, like I mentioned, we have the web page where we are trying to compare the different tools and how they work and what the best use case is for each one. So this has been enlightening. I thank you all so much. Everyone out there that is listening, thanks for sticking around. You can reach out to any of these people at Loka, and I believe they are all on the MLOps community Slack too. So if you want to reach out to them there, you can. And if you are watching this in the future, then leave us a like and subscribe on YouTube. That's all for today, folks. We'll see you later, and thanks again.